Hey, welcome to 11.5 Recursive Rules for Sequences. So today we're going to be talking about arithmetic and geometric sequences, and it's called Recursive Rules because we're going to be learning how to write recursive rules for sequences. So we've got two objectives today. One is to take a recursive sequence and find the first 5 terms, and the second objective is to write a recursive formula for arithmetic and geometric sequences. So just a review, we have already learned how to write rules for arithmetic and geometric sequences. We had our two different formulas that we learned in section 11.2 and 11.3. So we had our arithmetic formula and we had our geometric formula. And I can determine if something's geometric or arithmetic. If they give us a D, it has to be arithmetic. And if they give us a R, it's going to be geometric. So just a quick review. When I'm finding my explicit, and this is called an explicit rule, I'll talk about that in just a second, but I'm going to plug in my term 1, and you just leave as n, and then you plug in your d. Remember from section 11.2, next step would be to distribute the 7. And then last but not least, combine like terms. So for my final step, I have a sub n equals 7n minus 2, and that is my rule for the nth term, or my formula. The geometric sequences, remember, were easier and faster. Well, I don't know if you'd say easier, but faster, because I just need to plug in term 1 for term 1 and r for r, and there's nothing I can simplify for that one, so I'm just done once I've done that. So here's what you need to know. Those two things that we just found, finding all those sequence rules from section 11.2 and 11.3, those are called explicit rules. You can use them to find any term in the sequence, and what I mean is, if I wanted to find term 50, if I wanted to find term 100, all I need to do is plug in whatever term I'm trying to find, plug it in for n, or plug it in for n, depending on if it's an arithmetic or a geometric sequence, and I can find it just like that by using the formula. So there's another type of sequence, and it's called a recursive sequence. And a recursive rule, you cannot just find any term. You have to find a term using the previous term's value. And so actually, if I was going to find term 87 for a recursive rule, it would be really annoying because I'd have to list out every single term until I got to term 87. So a recursive rule is not used as often as an explicit rule for that reason. Now, just some math language for you. So we already know that a sub n, we've been using that a lot, that is term n. Now if I was going to make a list, I have a sequence here. Here's term n. We needed a way to represent this term right here that came before term n. So let's say, like, for example, this one is term 5. This one here would be term 4, and to get there, what I did is I subtracted 1 from the 5, so they denote that by a sub n minus 1. So a sub n minus 1 is how I pronounce it, and that means the previous term, the term that came before a sub n. So the term before the a sub n. And then, now think of it this way. Let's say that if I go two terms away from a sub n now, this right here is 2 values lower than 5. So that is going to be denoted by a sub n minus 2. And the a is normal, and then the n minus 2 are little subscripts. So a sub n minus 2 is two terms before the term we are looking at. And the term we are looking at, we'll say, is term n. And I want to tell you that this is all stuck together. You can't ever replace just n. You have to replace the whole thing. That's just special notation for previous term. I can't plug a number in for n right there normally. And let's say that I wanted to go one term after term 5. I add 1 to the little number, so that would be a sub n plus 1. So that's one term after term n. And just kind of for comparison's sake, I threw in a sub 1, which is term 1. But you will get the hang of this after a while, but it is a little confusing at first. So please listen closely, rewind if needed, and write down questions you might have. And I want to show you how this would look in an actual sequence rule. So right now, for example 1, we're going to have any type of sequence. It's not necessarily going to be arithmetic or geometric. And what we're going to do is find the first 5 terms of the sequence, no matter what's happening here. And so let me interpret for you. Here is my sequence rule. Now, if I have a 2 in front of a variable, it means 2 times. And I want to tell you again, this entire thing is like x. That entire thing is the variable. So that entire thing would be replaced by something. And if I was also going to say this statement in words, what's happening here is it's 2 times, or 2 multiplied by so 2 times, and then this symbol right here means previous term. So 2 times the previous term is what that means. And now let me show you what that means mathematically. I know that term 1 is 1. Here's what, in order to find my first 5 terms, every single time I am taking, my formula is 2 times, and if a good general rule of thumb is just put a parentheses where the a sub n minus 1 is, and we're going to fill something into there. And the previous term is the answer for what came previously. So what I mean is here, the previous term was 1. And then to find it, just 2 times 1 is 2. Okay, now I plug that in here. So every single time, I'm actually using the answer for the previous term, the one that came before it. I'm using that answer in order to find the next term. So that's what a recursive sequence does for you. So my sequence is 1, 2, 4, 8, 16. All right, let's do another one. So check out this. This one's even more complicated. So notice that a sub n minus 1 means previous term. So if I was going to say this one in words, I've got the previous term plus the term number minus 1. And once again, put the previous term, put a parentheses there. So that is where the previous term is going. And then here's how I want to interpret the rest of this. When it says plus n, that is the term number. And by the way, that minus 1 just came from right there. Okay, but the plus n, that's the term number. What I mean is, if I'm finding term 2, I put a 2 in there. If I'm finding term 3, I put a 3 in there. If I'm finding term 4, I put a 4 in. If I'm finding term 5, I put a 5 in. So I put the plain number of the term in for n, and then right here is where I'm going to put the answer from the previous term. So there's 2 different things going on. I'm using the term number, and I'm also using the previous term. Okay, so again, I would then put 2 right in there. 2 plus 2 is 4, minus 1 is 3. So term 2 is equal to 3. And again, I just took that guy and put it in right there. Now 3 plus 3 is 6, minus 1 is 5. 5 plus 4 is 9, minus 1 is 8. 8 plus 5 is 13, minus 1 is 12. So every single time I'm using the term I found to find the next term. And this just is confusing for a lot of students, so I'm going to do several examples here. If you feel like you understand, feel free to fast forward to example E. But example 1E. Fast forward to there if you feel like you understand right now. Don't skip example 1E and F though. Those are important. All right, if you need it, I'm going to go through C and D right now, so listen up. So this time I've got the previous term squared plus 1. I'm not using my term number this time. Okay, so I've got the previous term squared plus 1, previous term squared plus 1, previous squared plus 1. And as you can see, I usually do this actually. If I'm trying to find a bunch of different terms, I will go through and I will write out the setup, and now I just need to plug in what the previous answer was. So I start with term 1, 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. And every single time I'm putting whatever the answer was for the last term in the parentheses. 5 squared is 25 plus 1 is 26. 26 squared plus 1 is 677. Pause if needed, and when you have that down, we'll go on to example D. Now, this is confusing. Look, I've got my term number times the previous term. So, check this one out. I'm going to have my term number times my previous term. So, here's where the previous term goes. And then right here, I put the term number. So if I'm finding term 2, I put a 2 in there. If I'm finding term 3, I put a 3 in there. If I'm finding term 4, I put a 4 in, and so on. And then in the parentheses, that's where the previous term goes. So that's where I plug in what I got for the last answer. So 2 times 1 is 2. 3 times 2 is 6. 4 times 6 is 24. And then 5 times 24 is 120. With E and F, I now need to show you what to do when we're using the previous term and we're also using the term 2 spaces previous to my current term. And whenever this happens, they have to give us the first 2 in order for us to get started here. So I'm just going to put 2 parentheses and then I'll explain what as we go along. And we only need to find the first 5, but we're going to find the first 6 just so that we have more practice. Okay, so here's what I mean. Look at this. So the term, if I'm looking at term 3, the term, this means 2 terms before. So the one that is 2 terms before term 3 would be term 1, and the one that's just the previous term would be term 2. So term 1 is 1, term 2 is 1, so my answer is 2. And now, and just every single time think, okay, so a sub n minus 2, that is 2 terms before that, and this is just the previous term, so 1 term before that. So every single time I'm doing 2 terms before my current term, and then 1 term before my current term. And I'm just showing you in symbols what that would be, but really we just need to plug in the values. So here term 2 is 1. Term 3 is what we just found, which is 2. So now here I'm plugging in term 3 in here for the 2 terms before my current term. And here is just the previous term. And so this time I'm using 3 and 5. And I could keep going. So every time it's adding together the 2, like the previous term and the term before it. All right, one more. This time I'm doing my term that's 2 previous, subtract my previous term. I'm going to just get myself set up here, and I'm going to go to term 6 again just for some extra practice. Okay, and again, you don't have to pencil in what the terms are in symbols. It helps when we're just starting out here. So again, this is 2 terms before my current term. So if my current term right now is term 3, 2 terms before term 3 would be term 1, and then this one is just 1 term before, or the previous term. So 1 term before my current term would be term 2. So I plug in 2 and 2, and I get 0 for my answer. And so once again, for term 4, the one that would be 2 terms before term 4 would be term 2, and then term 3 would be 1 term before. And sometimes it can help students to just kind of, and again, this is optional, but I just want to show you in symbols what it would be. So now term 2 is 2. Term 3 is what I just found, that's 0. All right, term 3 is 0. Term 4 is 2. Term 4 is 2. Term 5 is negative 2. 2 minus negative 2 is 4. Go ahead and pause, rewatch if needed, and when you're ready, go ahead and flip to the back with example 2. With example 2 and 3, I'm now going to show you how to write an explicit and a recursive rule for each sequence, first with arithmetic, then with geometric. And by the way, if they don't tell you which one it is, remember, give a little note to yourself. We know it's arithmetic if given a D value, because D stands for the common difference. So if it, because when we get to the test, it's not going to say this is arithmetic, this is geometric. You just have to know if it's a D, it's arithmetic. If it's a R, it's geometric. Write that down someplace. That's what you want to memorize. Okay, and we're just going to practice here finding explicit and recursive. Explicit is what we did in 11.2 and 11.3. And recursive is the new thing today. So I'll show you how to do this. All right, here we go. So if I was going to do the explicit rule, again, this is review from section 11.2. To find my explicit rule, I plug in term 1. I plug in my D. I am going to distribute the 3, so I get A sub n equals, so term n equals 4 plus 3n minus 3. Combine like terms, so 3n, and then 4 plus negative 3 is 1. So that is the explicit rule. And finding the recursive rule is actually not difficult once you get the hang of it. What you need to do is decide what is happening to get the next term. What is happening to get the next term? So think about it. What does D equals 3 really mean? Think back to section 11.2. If it's a positive 3, that means that I am adding 3 to get the next term in the sequence. So in words, I'm taking my previous term in my sequence plus 3. So my previous term in my sequence plus 3. In mathematical symbols, previous term is denoted by this thing, remember? And then I'm adding 3 to the previous term, so there I am. Now, just a comment, to make a true recursive rule, you have to have the previous term in order to do this, so you always need to give people what the first term was so that they can get started to find term 2. Let's do another one. I'm going to look at example C. And this time, same problem, I'm just given the information in a different way. So I myself need to find term 1, and I need to find D, and if it's this type of thing, they will tell you if it's arithmetic or geometric, and actually, well, you can also determine it. It's sometimes kind of obvious, sometimes harder to tell, but here term 1 is 52, obviously. And if you look at my D, I'm going from 52 to 45. So if I go backwards, it's subtracting 7 each time. And just check yourself with whatever you think your D is. Is it really subtract 7, subtract 7, subtract 7? Yeah, that works. So then I found my A1 and my D. I'm now going to plug them into my explicit formula. So term 1 is 52. D is negative 7. Distribute the negative 7. So now I have got 52 plus negative 7n plus 7. Last but not least, combine like terms. So negative 7n plus 59. And for my recursive rule this time, so in my mind I'm thinking, what's going on here? And it is the previous term minus 7 is what's happening. So if I was going to write that in math language, I want the previous term, which is denoted by this symbol, minus 7. And again, you have to give them what your term 1 is so that they're able to find other terms in the sequence. I've got 2 more examples for you, B and D. So I'm going to have you try those on your own. I'm going to pause the video, and when you unpause, I'll have the answers showing. Good luck. Here's our answers for example 2, B and D. How'd you do? Again, write down any questions you might have. When you're ready, scroll down. We're going to look at example 3 next, which is doing the same process only with geometric sequences. So now again, I want to find an explicit and a recursive rule, only I'm doing geometric sequences. And remember, just note to yourself, we know it's geometric if we're given an R, and then otherwise you can figure out it's geometric. You can determine if it's adding each time or multiplying each time. Alright, so let's go for it. So to find my explicit rule, again, explicit rule is what we did in sections 11.2 and 11.3. So for geometric, I am going to use my geometric formula. I am going to plug in A1. I'm going to plug in R, and that's it. We love geometric because there's no simplifying to do. That's all. That's all. For my recursive rule, again, in your mind, think about what operation is actually happening. So if it's R is 0.1, remember that's what's being multiplied every time to get the next term. So what's happening, if I was going to say it in words, it is my previous term multiplied by 0.1. That is what is happening. My previous term multiplied by 0.1. So in math language, previous term is again a sub n minus 1, and then I want to multiply by 0.1. Now that gets a little messy looking. So here's how they usually write it. Usually they'll write it like this. And you don't have to have 0.1 in parentheses, but sometimes we do just so it's kind of more obvious that it's in front there. And then I say what is with it. A1 is equal to 3 is what is with it. Look at example C now. So this time I have to find A1 and R to start off with. A1 is the first term, that's 1. If I know 2 terms in a row, I can just do my term divided by previous term to get R. So R is 4. Here I go. Here's my explicit rule. Term 1 is 1. R is 4. And I don't really need the 1 there, so I can just write this for my explicit rule this time. And for my recursive rule, again, think in your head what is actually happening. R is 4 means every single time it's times 4, times 4, times 4, or multiplied by 4, multiplied by 4, multiplied by 4. So to represent previous term multiplied by 4, again, we want to put the 4 in front. So it's 4 multiplied by the previous term. And my first term was 1. You have an opportunity now to try B and D on your own, so go ahead and pause the video, and when you unpause, I'll have them showing. Okay, there's our answers for B and D. Again, write down any questions you have, and that's all I've got for you today. Have an excellent evening. Thanks for listening.